Okay, let's see how to solve some equations that involve exponents and or logarithms. So we'll work through some examples, and as we go, I'll try and say some things about general strategies and techniques for solving equations like these. So the directions for these examples are solve each equation, express irrational solutions in exact form, and as a decimal rounded to 3 decimal places. Okay, example number 1. ln, that is the natural logarithm of 2x equals 2.4. So in all of these, we're trying to solve, which means we're trying to find what x is. So to get x by itself on one side of this equation, first we have to get rid of the ln. To undo the natural logarithm function, we need to apply its inverse, the exponential function e to the x. So we're going to exponentiate both sides. Take e to the ln of 2x equals e to the 2.4. So e undoes what ln does. E to the ln of anything is just that thing. So 2x equals e to the 2.4. And now, of course, to go from 2x to just x, we would divide both sides by 2. So x equals e to the 2.4 divided by 2. Now, this is where I said to give answers in both exact form and as a decimal approximation. The exact form is what you see here. X equals e to the 2.4 divided by 2. If you need the answer exactly, that's what it is. Now, for the decimal approximation, this is where we get the calculator. And we put in e to the 2.4 divided by 2. Now, this particular model of calculator, I didn't have to really do anything else but e to the 2.4 divided by 2. But sometimes you might need parentheses around the argument of the exponential function. So on all of these, I'm going to try to show you how I'm doing them on the calculator, but I would recommend that you try putting them into your own calculator to make sure you're doing everything correctly, pushing all the buttons in the right order to get the right answer. And if you get a number that's different from what I'm getting, either figure out what you have to do to get the right answer or ask me about it. So here the decimal approximation, when I round to 3 places after the decimal point, is 5.512. Next example, e to the x squared equals e to the x plus 12. And because both sides are just e to the something, that makes it easy. The somethings have to be equal. And one way to think about what's going on is to undo the e, you can use the natural logarithm function. ln of e to the anything is just that thing. So you can think, here what we're doing is we're taking the natural log of both sides of the equation. If this equals this, then ln of this equals ln of this. And ln undoes the e. ln of e to the something is just the something. And so we have x squared equals x plus 12. Okay, how do we deal with that? Well, that is a good old-fashioned quadratic equation. It's an equation that involves x squared. Remember how we solve those? Start by getting everything on one side equal to 0 on the other side. So x squared minus x minus 12 equals 0. And then we could either use the quadratic formula, or here we could just factor. This factors into x plus 3 times x minus 4 equals 0. So that means x plus 3 equals 0 or x minus 4 equals 0, which means x equals negative 3 or x equals 4. So those are the two solutions. If x is negative 3, we get e to the 9 equals e to the 9. That's true. If x is 4, we get e to the 16 equals e to the 16, and that's true. Okay, next example, 2 minus 6 ln x equals 10. So we're going to try to get the ln of x by itself on one side, and then go from ln of x to just x to get our final answer. Now, first of all, can we go ahead and subtract 2 minus 6 and get negative 4 ln x equals 10? No, that would not be legal because we're not allowed to subtract before we multiply. That would be breaking the rule about the order of operations. So the multiplication comes before the subtraction. Okay, so what can we do? Well, we can get rid of the 2 over here by subtracting 2 from both sides of the equation. So now it's negative 6 times ln of x equals 8. Now undo this multiplication with division. Divide both sides by negative 6. So ln of x equals, and then 8 divided by negative 6 in lowest terms would be negative 4/3. So now we do have ln of x by itself on one side, and to go from ln of x to just x, to undo the ln, we exponentiate both sides. We take e to that. So e to the ln of x would just be x, and we have to do it to both sides, so that's equal to e to the negative 4/3. So the exact solution is e to the negative 4/3. And the decimal approximation on the calculator, if I ask the calculator for e to the negative 4/3 power, it tells me that that is 0.263597 and so on. So to 3 decimal places, it's about 0.264. Next example, base 2 log of 2x minus 3 equals the base 2 log of x plus 4. Okay, do you see what the first step here is? Well, both sides are both base 2 log of something, so the somethings have to be equal, right? And in a way, what we did to get from step 1 to step 2 is, you can think, to undo the base 2 log, we use the exponential function 2 to that power. So 2 to the log base 2 of 2x minus 3 is just 2x minus 3. On the other side, 2 to the base 2 log of x plus 4 is just x plus 4. So now we just have to finish solving 2x minus 3 equals x plus 4. Subtract x on both sides, add 3 to both sides, we get x equals 7. And of course that does work, because then we have base 2 log of 11 equals base 2 log of 11. Next example, base 3 log of x plus base 3 log of x minus 8 equals 2. Now this one is not as simple. On one side we have 2 separate logarithms. On the other side we have just a number. What can we do? Now remember those 3 properties of logarithms that we talked about in the last section. The one that says the log of one thing plus the log of another thing equals the log of the one thing times the other thing. The sum of the logs is the log of the product. And then we had one that said the log of one thing minus another thing equals the log of the first thing divided by the second thing. And we had one that said that a number times the log of something is the log of that something to that number power. So here, to combine these 2 separate logs into one big log, we use that first property. The log of one thing plus the log of another thing is the log of the 2 things multiplied together. So log base 3 of x squared minus 8x equals 2. Now how do we get that log out of the way? How do we move the log? We undo it with its inverse exponential function. We take 3 to that power. 3 to the log base 3 of something is just the something. So we're going to do that on both sides. 3 to this power equals this, and 3 to the 2 power, well, 3 to the 2 power would be 9. So x squared minus 8x equals 9. That's a quadratic equation. Get everything on both sides. X squared minus 8x minus 9 equals 0. Now, factor x minus 9 times x plus 1 equals 0. So x equals 9 or x equals negative 1. However, we have to disqualify that x equals negative 1, because if we went back up here and tried to plug in negative 1 for x, we'd have logs of negative numbers. And that's not allowed. The log of a negative number is undefined. So negative 1 is not a solution to the equation we started with. It's not something that we can put in place of x and have the two sides be equal. 9 is a solution. The base 3 log of 9 would be 2, because that's the power you have to raise 3 to get 9. The base 3 log of 9 minus 8, the base 3 log of 1 would be 0, because that's the power you have to raise 3 to get 1. And then 2 plus 0 does equal 2. So 9 is the only solution to that equation. Let's try this example. Negative 2 times the base 4 log of x equals the base 4 log of 9. Now, if both sides were just the base 4 log of something, that would make it easy. We can undo the base 4 logs and get the somethings equal. Right now, we don't quite have that. This is not just the base 4 log of something, it's negative 2 times the base 4 log of something. But we can use that property that says that something times the log of something equals the log of the something to that thing as a power. So we can rewrite negative 2 times log base 4 of x as log base 4 of x to the negative 2 power. Now for log base 4 of x to the negative 2 to equal log base 4 of 9, x to the negative 2 has to equal 9. Remember what x to the negative 2 means? It means 1 over x squared. So 1 over x squared equals 9. Multiply both sides by x squared, and you can say 1 equals 9x squared. Divide both sides by 9, we get x squared equals 1/9. And normally when you get x squared equals a number, you say x equals the positive or the negative square root of that number. X equals 1/3 or negative 1/3. However, here, x is something that we are taking a logarithm of. So it does not work for x to be a negative number. So the only thing that really is a solution is positive 1/3. Okay, I'm going to stop this video here. That's the end of part 1. I'll come back in part 2 and we'll work through some more examples and see some more tricks.